Assalamu alaikum students. Today we want to practice a small program which is related to the solution of quadratic equations. Although all of you must have studied the quadratic equations, but just to begin with, I am showing a brief introduction to it. It basically deals with projectile motions. Two type of projectile motions have been shown on screen. One, for example, if somebody throws a ball, it follows the trajectory of a parabola and falls at some point. Similarly, if a projectile is thrown given initial velocity, so when it will fall down on earth, that is something which can be calculated using quadratic equations. It can have a lot of other uses as well, but I'm not going into that detail, but just to show you what we are going to do today. So we are going to solve a quadratic equation, and how does it look like? Ax square plus bx plus c is equal to 0. That is a quadratic equation, and it has roots which are actually the solution of the quadratic equation. The roots can be real, they can be repeated roots as well, or they can be imaginary roots. So how do we solve it? Let's see step by step. So I'm going to use Colab notebook for the same for this purpose. So let's begin with the code, and I'm going to begin with same title of the code using hashtag the comments feature in Python, quadratic equation roots calculator. And let's also write down how does a quadratic equation look like. It is like ax square plus bx plus c is equal to 0. This is what we want to solve. At this stage, I am going to import a library called cmath, and we need this cmath library for handling imaginary roots. I can write it down here, for handling imaginary roots. Now we will see this cmath, its use later on in the program, but the first step for us will be inputting of these variables a, b and c. We need the value of a, b and c. We can either store a value directly in these three variables, or we can take input of the variable from the user. For example, I can say a is equal to 1, b is equal to 2, c is equal to 3. However, in this program, I am going to take input of variables from user. So a is equal to, initially I am going to write down the input command directly. Later on, we will convert this from string data type to numeric data type. Enter. Coefficient a. So this is how we take input in Python. We have discussed this numerous times, that by default the input is in string data type because we want to use these coefficients for calculations. So we should convert them to numeric data type. Two types of conversions are usually used, integer and floating decimal places numbers. Here I am going to use float command. So that even if a decimal value is added, that can be considered for calculations. So now I am going to copy paste the code to create two more variables a, b and c. Now at this we have taken input of all the three coefficients. Now after getting the value of a, b and c, we need to calculate discriminant. What was that? B square minus 4ac, and this is the discriminant which tells us about the roots being real or imaginary. So let's start. I'm going to give another comment so that later on we can relate to it. Calculation of discriminant. Let's say there's a variable called capital D to store it, b square minus 4 multiplied by a multiplied by c. So look at here, 2 times static. 2 times static means raised to the power. Whenever we want to take power, we use double static. Single static is used for multiplication like it has been done here. 4 multiplied by a, which is multiplied by c. So now we have calculated the discriminant, and then comes check for real oblique imaginary roots. At the stage I am only going to choose two, real and imaginary. Repeated roots will be added later on. So we need to have if command here. If the discriminant is greater than 0, then we have real roots. Real roots code. I will add the code later on. Else imaginary roots code. So later on I am going to convert these real roots code and imaginary roots code, replace these lines with the real codes, or maybe we can convert them to comments at the same stage. What if I want to include repeated roots which are actually real roots? So instead of displaying two different the same value twice, we can maybe display the value once. For that we can use else if. And what is the command for else if? ELIF. D is equal to 0. Again remember, I told you that whenever we want to check equality of what's stored in a variable, we use double equality. Single equality is used to create a variable or store value in a variable, and after this else if we'll have repeated roots code. Now at this stage we can add our code. If the discriminant is greater than 0 and we are expecting the real distinct roots, we can calculate both the roots like this. Root 1 is equal to the code was minus b plus discriminant square root of the discriminant divided by 2a. So either I can use the command of square root, or I can simply write raised to the power 0.5. Each of these can be done. So currently I am going to do this, minus b plus discriminant raised to the power 0.5 divided by 2 multiplied by a. So that is root number 1, and I am going to copy it for root number 2 and will replace this plus with a minus, so we get our two roots. Both the roots have been calculated, and now is the time to print the answer. So print and I am going to use formatted printing, so I am using f discriminant is equal to, let's take the value from the variable d, which is greater than 0 in this case, roots are real and distinct. And then we can print both the roots. Print, again formatted printing, root 1 is equal to, let's bring the root value from the variable called root 1, and I can simply copy this code again to get the value of root number 2. Now this is the code for the real roots which are supposed to be distinct. Now comes the code for real but repeated roots, means root number 1 and 2 both are actually same. So we need to calculate only one root, and that is going to be root is equal to minus b divided by 2 multiplied by a. That is a formula for the repeated root, because actually the discriminant is now 0. So we can again copy the print command and simply change that discriminant is equal to 0, and we can say the roots are real and equal, and one of the root variable with smaller I can keep the capital in the text, but the variable name needs to be exactly same from the perspective of case as well. So this is the code for repeated roots, and now comes the last part where we have the imaginary roots. Now at this stage we cannot use raised to power 0.5 because now the discriminant is negative and we cannot directly get square root of a negative value. So we need to use cmaths library, and from the library the command cmaths dot sqrt square root. Now this square root command can calculate square root of both real and imaginary values. I mean negative values. The square root for negative values can also be calculated, and the result will automatically include an iota value. I hope you guys remember what is meant by iota. That was for the negative values, square root of minus 1. So now we have root 1, we have root 2 with change of the sign only. And then I can again copy the command of printing from the first part in order to save the time. Discriminant is less than 0, which means it's negative. The roots are imaginary, and the root 1 and root 2 can the code remains the same. So this is the code that we have got. Now we have directly written the code, and I hope the code works fine. Let's run the code at this stage and see if we get the correct values or not. So let's run the code and see. Okay, it's working fine up to the initial input stage. So I'm giving the value of a as 1, and I'm intentionally putting those values of a, b and c coefficients so that I get two real and distinct roots in this first check. A is 1, b is minus 5, while c is 6. Now the roots are 3 and 2, and the answer is actually correct. So it means that our first part of the conditional statement, if where the roots are real and distinct, that's working fine. Let's run the code once again and see if the code works fine for two real and equal roots. So I'm going to put a as 1, b as minus 4, and c as 4. The roots are discriminant, as you can see, 0. Roots are real and equal. You can improve this text message, and the value of root is 2. Actually, there are two roots. If you want to say it in that way, both are 2. Practically, it's actually one intersection of the line. Now let's run the code once again and see if the imaginary part, the else part, runs fine or not. So I'm gonna give A the same value 1, B will be 2, and C will be, let's say, 5. Now we should get imaginary roots, and here you see -1 plus 2 iota. Python by default writes j from CMath library in place of iota. -1 -2 j. So these are the two imaginary roots. So it seems that our code is working fine. I am not going to share the script of this code with you guys at this stage. I'm going to leave it on to you to practice the quadratic equation code yourself. And if you get any issues, you guys can share with me. Thank you very much. Jazakallah and best of luck.